Welcome to Automation Chat. I'm really glad you're joining me today. I'm your host, Theresa Houck, Executive Editor of the Journal for Rockwell Automation and our PartnerNetwork magazine. This is another editorial series episode in which I discuss my take on important issues that affect you and the industry. Today, I'm talking about advanced analytics in industrial automation and their role in improving business results for any size manufacturing company. I also chat with Chirayu Shah, Product Head of Edge to Cloud and Analytics with Rockwell Automation. You'll learn about descriptive, diagnostic, predictive, and cognitive analytics, what each type is and why they're important. Learn what it means to understand the context of your data, and see how edge and cloud technologies are evolving to process data at much higher rates and how they're fueling artificial intelligence and machine learning to create models that produce more accurate results in your efforts to increase efficiency and business results. You'll also get real-world examples of how manufacturers are using analytics to prevent potential problems and identify opportunities to increase productivity, reduce operational risk, or improve system interoperability, which I cannot believe I said that word without stumbling over it. And you'll find out key trends and why they matter to you. But first, it's time for our family-friendly, silly joke of the day. Helium walks into a bar. The bartender says, "We don't serve noble gases here." Helium doesn't react. So in my April podcast about industrial automation trends in 2022, I explained that one significant trend is the use of data analytics to increase business value. That's because industrial analytics solutions gather data from your operations and puts it into context. Those insights can help you achieve business outcomes like overall equipment effectiveness, or OEE, downtime reduction, quality improvement, and process improvement. Manufacturers no longer want a plant manager or maintenance worker studying historical data from a spreadsheet to make a minor change. Manufacturers still need to evaluate machine data to develop production efficiency, decrease downtime, control costs, and support better decision-making as industrial assets are digitized and connected via the Industrial Internet of Things, or IoT. This will help them build smart, flexible operations so assets and systems can be automated and improved in real time. Now, making sense of massive amounts of data generated can be challenging. To get the most out of the system, you'll need to find the suitable data analytics software platform and then create a proper process. And it doesn't matter how large you are, if you're a small company, large, medium, doesn't matter. Now, most, if not all, industrial analytics platforms use artificial intelligence, or AI, and machine learning, or ML, to identify patterns in the massive amounts of data that the plant floor creates. And they use that data to create models of assets and plant floor activities and automate processes. In fact, advanced analytics powered by AI and ML is the backbone for intelligent operations like predictive maintenance, real-time quality control, and scenario testing for root cause analysis. And AI-driven analytics model can help create a digital twin so manufacturers can simulate tests and optimize its processes. So analytics solutions use advanced analytics software and dashboards to help manufacturers increase visibility into what's happening on the plant floor. And this helps optimize their data and provide their return on investment. It's a really powerful tool to measure OEE, which, in case you're not familiar with the term, is an important calculation that considers equipment availability, throughput, and product quality. The analytics software program uses real-time data and machine learning to identify trends that predict downtime and other problems. It's displayed on a dashboard, which is a really important tool for the user. And the software can spot abnormalities that might predict new failure modes or other problems. These insights provide advance warning so you can take action before an unplanned shutdown occurs. That lets you proactively service parts or equipment to avoid situations like missed customer orders and quality issues. One example is when AC drives using predictive diagnostic settings use them to monitor drive and motor operating conditions to show you the true remaining life of the drive's components. Now, I also discussed in my April podcast that a trend we're seeing in industrial analytics is the emergence of what has been called the OT citizen data scientist. This is related to artificial intelligence and machine learning. In the past, machine learning models were created by data scientists, but now easy-to-use tools are allowing even non-data scientists to use machine learning libraries and build models. So now there's growing interest in making AI and ML much more accessible, and manufacturers are engaging employees with a variety of domain knowledge to contribute to better analytics initiatives. So there are more and more OT engineers, IT analysts, data scientists, and citizen data scientists increasingly getting involved in creating machine learning models and participating in the digital revolution. People want the ability to collaborate and participate while building AI and ML models, and it's all tied to advanced analytics. Now consider this. Where all this data is stored is an important decision when you're setting up your analytics platform. Industrial analytics software often requires robust edge processing abilities because of the need to handle and analyze data in near real time and close to the source to prevent latency and for security concerns some users have. And let me note here that the truth is that the cloud is a secure environment, and it's a common misconception that it's not. The fact is that many companies use a hybrid approach where they use both the cloud and the edge. I talk about that and much more with Chirayu Shah. So let's enjoy our chat now and let's see what he has to say. Hi, Chirayu. Thank you for chatting with me today. I'm glad you're here.
Hi there. Happy to be here and looking forward to our conversation.
So let's start talking about advanced analytics, but first, how about you tell me about a little bit about your background and also what you do at Rockwell Automation?
Yeah, happy to. So my name is Chirayu Shah. I work at Rockwell Automation, been with the company for 21 years, all in software space. I was a software engineer at first. I lost my credentials a long time ago. I went into the business side. And last 10 years of my life, I've been in the business side, responsible for product management, acquisitions, business development, partnerships, had a rotation in Australia for a year, quite a different experiences that I've been really thankful for. And my current role is product lead. So I'm responsible for all the product management and marketing function for analytics as well as edge to cloud portfolio. So all the FactoryTalk Analytics as well as FactoryTalk Edge and FactoryTalk Hub. So looking forward to our conversation today. And
This should be interesting. And I like hearing that you started 21 years ago. I started here at the Journal magazine about 17 years ago. And I like to tell people I started when I was 12, but nobody believes me.
I was 10 probably.
Yeah, I think it would break a few child labor laws, but
yeah.
Okay, so it sounds like you know what you're talking about when it comes to analytics. So let's dive into probably our biggest question. I know there are 4 general areas or types of analytics: descriptive, diagnostic, predictive, and cognitive. So for our listeners, can you kind of describe what each one is and what they mean and why they're important to manufacturers?
Yeah, absolutely. So look, I won't claim that I've created these definitions. These came from Gartner when they defined the analytics purview on how different solutions are evolving in this space. Descriptive really at a base level means it tells you what happened in the past. So it's really rear view mirror. Diagnostics based analytics are the ones that help you understand why something happened in the past, right? So there is something happened, you got descriptive, why something happened, that's diagnostic, so you can drill into it. Predictive really talks to what might happen in future, right? There is an event that it's predicting that will happen in your process. And cognitive or prescriptive really recommends actions that you can take to overcome the event that might happen in future, right? So if you look at from spectrum of solutions and evolution and analytics space, you want to know what happened, why it happened, something is about to happen, and what can I do to prevent it from happening, right? So that sort of is the spectrum of analytics and how different definitions are put forward. Ultimately, and what it comes down to is we want to make information available to people so they can be more productive in making decisions and making sure that they get the most out of their engineering and process and operations.
Okay, well, I know a lot of what we cover in the journal deals with the predictive aspect.
Yes.
And so that's a big deal because that helps alleviate a lot of downtime, a lot of maintenance costs, and sometimes labor costs.
Yes.
But do you typically see the need for kind of an equal amount of those types of analytics being applied, not just mostly predictive?
Yeah, there is multiple vectors to this. The first vector is who is looking for that information. And if you are an operator sitting in front of a terminal operating a machine, you tend to want to get more of the descriptive information so you can actually do something about it because you're looking at real-time, high-speed data as you're operating that machine. But if you are a line supervisor or a process engineer, you're looking at more of the historical data to analyze and diagnose problems that are reoccurring, or you want to start to predict those failures to prevent the costly downtimes that you're speaking to, right? So, and then you're into the data science realm when you're trying to solve problems across multiple vectors of data sources that exist in industrial space. And you start to sort of predict and provide actions and alerts to people who can take reasonable actions before those failures occur. So to me, the context and the persona that's requiring that information dictates a lot of times what tool is right for that job. So that's the first aspect. The second aspect is I started to alluding to it in the persona discussion, which is around the nature of this data, how granular that data is, the high-speed nature of that data, how frequently it's changing, what are the contexts of that data in context of that machine or the line, and then also what are the other variables that are affecting that process. Maybe it's the weather data, maybe it's supply chain data, maybe it's ERP system data. So there are a lot of things that you need to decipher through as a plant manager or a plant supervisor or a plant operator. And depending upon the nature of the need and the data context, the tool changes as well. And then the third vector to this is around just the evolution in analytics and the technology, right? So initially, the technology was all around historical rear view mirror. We could collect a lot of data, and then we can create trends and we can create dashboards so you can see something when something happened in last shift or 2 days ago or 5 days ago and compare that with your current shift. That was very typical use case for your golden batch analysis or just your process data analysis or your OEE for that matter. What we are seeing more is both from edge and cloud perspective, technologies are evolving that allow you to now process this data at a much higher rate and be able to create these models that can help churn better results and more accurate results that you can bring back to your process or the user to solve those problems. And that's where sort of this closed loop piece comes into play, right? So this idea that the data is available for me to look at what happened, but also now I'm learning in real time and bringing that data back to the user to make decision. So if you look at the evolution of analytics space and industrial perspective, there was a lot of descriptive tools and they continue to be around because there is value for that for specific use cases into more of the predictive and cognitive pieces. And So I look at it as the spectrum of capabilities that we make available as technologists, and then we look for problems that can help solve using these tool sets. So hopefully that aligns with what you're thinking, but I'm happy to clarify this further.
Yeah, that makes complete sense. And it's taking a massive amount of data and putting it, as you said, into context. Like you can look at your data, but what's it mean to happen with that pump or happen with that PLC when it functioned this way? And the context means everything. And you also mentioned the edge and the cloud.
Yes.
And I think a lot of manufacturers wonder, well, which one should I use, or should I use them both? And is that something that's an individual choice depending on the application?
Yeah, it's a very good question. So we look at it as edge to cloud as the two sort of platform pieces where we're going to execute some of these analytics and drive value for our customers. What we think is there is a need for us to use a cloud environment to train models when you're dealing with complex data sets and multiple sources of data where you need compute surface to analyze that data source across a large spectrum. We think cloud is a great way to configure, align, and then learn from that data sets. But then we also believe that some of these problems can be solved on the edge using edge compute and even bringing things back into the controller to optimize the process. So what we believe is edge to cloud is the scaling mechanism to solve these problems. We believe that edge could serve a purpose where there is a latency and high speed aspects to data that we can protect and serve at the process level. And then we also want to participate in larger enterprise journey where customers bring into this hub all these different data sets and then trying to solve interesting problems across supply chain. So when you think about those use cases from farm to fork, or you think about the entire end-to-end supply chain for a manufacturer, there are a lot of dependencies that gets built into the process based on the environmental variables, business factors, consumer preferences. And at that scale, they need a lot more context. And for that, they need scale of cloud to bring all these things together. From manufacturing perspective, when you go into the facility, when you're producing that product, then you need some of that high-speed data and analytics right at the edge so you can be better at producing and meeting your orders. And for that, we do need some elements being executed on the edge. And the next-gen tools will just get better and better around how we do closed-loop analytics on the edge. I'm happy to talk through that as well.
Yeah. And just another question. If I'm a small manufacturer or medium-sized manufacturer, can I still use analytics software platforms, or is that more for the larger companies?
That's another great question. So we don't think, let me restate, we believe in democratizing data and analytics to everybody in the world, because all of our lives are better for it as we think about personal lives as well as professional lives, as we analyze what we do and how much data we consume and what we can do to improve our lives. For manufacturers, what Rockwell does really well is bringing that context of and domain expertise that we know of for all these years of working in these plants and bringing the technology that we work with likes of Microsoft and others in our partner ecosystem. We bring those worlds together and we are able to then deliver closed loop analytics capabilities that are buzzwords worthy like artificial intelligence and machine learning. We're able to demystify those capabilities into solutions that we can bring to those manufacturers so they can really use their expertise in operating their plant and mapping their data sets to capabilities that we have and help them improve what they do on a day-to-day basis to get more out of their investments from automation perspective. I'll give you an example. One of the things that we're doing is helping our customers around process optimization, where we provided capability next to their controller. And the data that we were collecting from the controller, we were able to train a model, a machine learning model, and then we were able to write that output back of that model into the controller So the controller can then self-govern and self-optimize the process. That's an example of closed loop analytics where we can train the models and we can improve the process or the machine from our domain expertise and tools that we are very appropriate for OT persona and also for a lot of small to medium-sized customers who are using our products in industrial space.
That's a great example. In fact, it'd be nice to hear a couple other examples because I know that software platforms, their goal is to increase efficiency, reduce operational risk, improve system interoperability, which I can't believe I just said that word without stumbling over it. So do you have any other examples you can describe about how that has helped some of your users?
Yeah, absolutely. So one of the things I would share is ultimately Rockwell is built on productivity. We provide productivity to industrial customers. So when we build these analytics solutions, we are looking to improve that process. Historically speaking, we drove operational efficiency through OEE type calculations for a lot of our food and bev customers, a lot of our automotive customers. And what you see now is just the growth in that from the process perspective and how we are solving problems for larger customers with more complex sites. So, we are into oil and gas industry or chemical industry or specialty products industries. In all of these spaces, we are able to apply these analytics modules to drive specific productivity. I'll give you an example that you're seeking. We had a large customer of ours, who was producing coffee, and they were trying to find the right formula that drives the right temperature and the coffee beans, and then the right temperature of the production of the coffee. We were able to collect data at a sub-second level to help them train the model in the most effective way that we can then bring back into their process and help them build a standard approach to get to those levels every time they ran a batch. So that's sort of examples where we can get them to optimize their production, but also produce premium product so they can win in the market and be very, very successful. Building at high capacity and with low downtime from our perspective is our ultimate objective to drive that productivity. So there are many examples out there. I'm happy to share links with you afterwards that your audience can see it. But we're quite thrilled with some of the problems that we've seen in real world that we are helping solve right now.
That's great. It's good to hear specific examples. And I know that the analytics are just, the use of analytics software is just increasing and there are reasons for it. What are some of the trends you're seeing? What do you see happening now and in the next few years?
Yeah, it's a great question again. So one of the things that you will see is this idea that, today the customers are in the process of, I have a analytic that's being run based on data that I've collected. And what happens is you got a controls engineer who's responsible for the control side. The data aspect gets routed to some data management system and analytics system. And then you got data scientists who are building data models. And then they're sending information back to a control system person. And then they are going and tweaking the bits and optimizing the process. That process that I just described takes weeks of interaction and updates between humans to work through this. What we are seeing the trend in future is around autonomous, where we can bring in those learnings directly into the controller and then optimize that process. So this handoff of a data scientist working through a model, going through a controls engineer and then updating it, which could be an error-prone or a cumbersome process. What we're now seeing trending technology is we can bring that model learning process directly into close to the controller, if not within the controller, so that we can then provide more optimization in real time as you are executing production runs from manufacturing perspective. So this idea that autonomous learning, leveraging AI capabilities and models that we have developed that can be brought into the process, into more of the evolution of model predictive control and how we can do autonomous learning is where the future is going from analytics perspective. That doesn't mean that we won't do descriptive analytics. That won't mean that we won't do some of the other diagnostic tools as well. But you will start to see more of the predictive maintenance, prescriptive things built into the learning model back into the process autonomously, which is where we can drive a lot of optimization in near real time for customers.
That's really powerful.
Yes, we're quite excited about it.
Well, is there anything else, another trend or anything you want to mention, or that anything that you want listeners to know about for analytics?
No, I think we covered a lot of good things. We will be at Rock Live in June. We'll be demonstrating some of the new capabilities in analytics. So please come join us then. But otherwise, reach out to us anytime. We'd be happy to answer any of your questions through our standard mechanics.
Great. I'll be at Rock Live too. So I'll be sure and stop by and see you in person.
Absolutely.
Well, this has been very useful and fascinating. I really appreciate you talking with me today.
Absolutely. Pleasure's all mine. Thank you so much.
Thank you. It's a great discussion. And I'm Theresa Houck with the Journal Magazine. We'll talk again soon.